Most mummy portraits are painted on wood. Some are actually painted on linen or papyrus, and they date to the 1st to the 3rd century AD, when Egypt was part of the Roman Empire. About 1,000 survive worldwide, some attached to mummies and others as detached portraits. Although there are regional variations in the panels excavated from different parts of Egypt, a high proportion of the panels are made from Tilia europea, limewood or linden tree. The selected tree would have been felled and cut into logs with an iron axe, such as this replica example. Planks from the lime would not have exceeded 300 millimetres in width due to the diameter of the trunk. These planks were left to season. This is a process of drying the boards naturally, and it could take as long as a year for the planks to actually dry. Limewood has a perfect combination of properties, but it does not grow in Egypt and therefore had to be imported. The panels may have been cut into veneer in another part of the Roman world, close to the source of the lime, and shipped to Egypt in veneer form, or may have been cut in Egypt from larger pieces of wood. These two examples of portrait panels in the Fitzwilliam Museum in Cambridge, both about 2 millimetres thick, have been identified as limewood. It's most likely that the panel inserted into the Red Shroud mummy is also limewood, although it has not been possible to take a sample from the board for analysis. What we have here is a typical limewood board, after the sapwood and the bark have been removed. It's about 300 millimetres in width. Limewood was used because it was soft and carves easily, has got a fine straight grain with very few defects such as knots and shakes. Dr. Lucy Rapson will be recreating the process used to paint the wooden portrait panel of Demos, which is in the Egyptian Museum in Cairo. And I will be making the panels on which Lucy will paint. What we have here is a frame saw with a blade tensioned horizontally through the centre. The blade actually runs through a pair of guides, and the block that we're sawing is anchored into the actual guide itself. And as we draw the blade to and fro through the guides, we actually cut a veneer of limewood. Roman woodworkers would have used an iron blade in their frame saw. Iron blades are not as flexible as steel blades and would have sawn a truer line through a block of wood. Cutting these veneers is a labour-intensive process, taking us an hour and a half to cut one veneer. Using the guide in the vertical position, you can saw faster through the actual block of wood as you're able to put more pressure on the saw blade. A pair of younger men or boys would have sliced a veneer more quickly from the board. But another way to speed up the process is by increasing the length of the blade. My experiments have shown that a saw with a pitch of 6 or 7 teeth per inch or 25 millimetres achieves the best cut and produces saw marks on the back of the panels, which is similar to those seen on their ancient counterparts.
This is the back of the male portrait in the Fitzwilliam Museum. We can see those same marks from the saw going at right angles to the grain and right the way across the panel.
The mummy portraits themselves are between 200 and 250 to 300 millimetres in width and 350 to 400 millimetres tall. Most of the surviving panels are just a few millimetres thick and often retain a convex curve which fitted over the mummy. Now this could be due to the natural cupping of the timber as it was sawn into a veneer, or created by a process of steaming, which is used to shape wood and was known in Egypt from the Middle Kingdom onwards. Some of the surviving panels are made from timbers including trees that were native to Egypt. For example, the portrait of Didyme, a young child in the Fitzwilliam Museum, is made from sycamore fig. This wood was used commonly in Egypt to make coffins, But whilst it's got good structural strength for making planks, it does not have the anatomical features needed to allow it to be cut into thin boards that would be strong and flexible and could be planed and sanded to a smooth surface. The panel of Didymi is between 12 and 15 millimetres in thickness and is flat. In order to cut the 2mm veneer, two carpenters operating the frame saw would have had to have been highly skilled in the use to achieve a uniform thickness. Only a slight change of blade angle would result in the saw breaking through the surface of the timber or going deeper into the plank from which it was being cut. Egyptian and Roman carpenters used tri-squares, and this is a replica example of an Egyptian tri-square. They also used mitre squares. This is an Egyptian mitre square, this is a Roman mitre square. The advantage of the Roman one is that it incorporated a template on the end that allowed them to set their plane blades in order to do mouldings that were attached to furniture. This is an adze. This was the tool that planed in ancient Egypt, but essentially it chops the wood rather than slices the wood. This is the typical way the adze was used. The Romans used the adze blade but turned it around, and they realised they could plane wood with a reverse blade. They fixed the reverse blade into either a metal or a wooden block, and that became the plane which they could then use to uniformly cut thin pieces of wood from the log. We're using a straight edge. What this is showing us is this part of the panel is thicker than this part of the panel, and we're going to remove this section by planing. These marks are plane marks manufactured by a wide plane blade, and these smaller marks are produced by much finer blades. These are the type of marks that we often see on the backs of mummy portrait boards. This is called a bullnose plane. It's got a blade of about 15 millimetres width, and it's used to smooth the surface of flat panels. It will give you thinner plane marks, but also it takes off less material, so it will give you a finer finish.
Jeff demonstrated how boards may have been thinned down by the use of a plane. This is the back of the female mummy portrait in the Fitzwilliam Museum, and we can see very clearly that there are plane lines here running along the length of the grain. It's a small plane. It appears to have had a blade which was about 15 millimetres wide, and they're very easy to spot in a raking light because there must have been a nick in the plane blade, which is reproduced across the whole width of the board with every stroke of the plane.
The process of sanding involves rubbing a sandstone block along the surface of the wood. This smooths the surface of the wood, which also reduces the panel in thickness. Developed from the knife, we first find Egyptian saws around 3100 BC. Along one edge of the saw blade have been nibbled out teeth, and they are pushed to one side, which does make it a little more difficult to use. I'm sawing the edges or corners off of this mummy portrait in order that it will fit into the mummy wrappings.